So the next chart that we want to look at is called a scatter chart or a scatter plot. So this is what we have done. We've already seen this at the beginning of the very first video with the quartet of data that motivated us for exploring data visually in addition to just looking at summary statistics. So again, this chart is useful for trying to look at possible relationships or associations between two different variables. The most important thing really is if we are surmising or hypothesizing that one variable is causing or influencing the other, then the response or dependent or outcome variable should be on the y-axis, the vertical axis. The thing that we think is doing the influencing or causing the response variable to react the way that it does goes on the x-axis. If you get them flipped, then you're in a lot of trouble. So the first thing you should do is think about what is it that is the response or dependent or outcome variable. Put that on the y-axis, and then the thing that's causing that variable to react or change goes on the x-axis. So let's go to Blackboard and get some data for this. So under Materials Unit 2, we're going to use BLS, which stands for Bureau of Labor Statistics. And this, I grabbed this data from, I don't remember, the Bureau of Labor Statistics at some point, where it's basically a survey that they do over multiple years, and this happens to be one snapshot, where I have the ID, whether or not they're a female. 1 means they're a female, 0 means they're not, their age in years, their height in inches, and their weight in pounds. And so what we'd like to be able to do is say, well, what might be relationships between two different variables? So I think one thing we could think about is how does the person's weight become affected by the other possible variables, their age, their height, that kind of stuff. So probably the most logical or immediate thing that we could think of is that the taller a person is, generally the more they weigh. So we're going to say weight is affected by height. So we would think that the bigger the number height is, the bigger the number the weight is. So there'd be some kind of upward trend that would go that way, an upward pattern. So to do this, if the x variable is already on the left-hand side, we can simply select all of the data, the x and the y, make sure x is on the left, y is on the right, and then we can go to Insert, Scatter Plot, like this. So when we do that for this particular data set, the y-axis looks like it is weight, like we expected. We get a big clump of data out here. That's not what we want. So what we want to do is fix the axes. So it looks like we're down here for height, somewhere around 60 is the minimum. So let's right-click on the axis, the x-axis, do Format, and change the minimum to, let's try 58 and see what that does. Okay, it doesn't look like we lose any data that way. And then let's close it. Now that's a little more readable, right? Notice too that the y-axis starts at 0. Looks like we're down at 88 is kind of the smallest for weight. So let's format that to like maybe 85. I don't like that. Let's go 80. I didn't like it because the dot was going over the thing. Right? And it'll automatically set the maximum to an auto for us. Okay, so now we can read this a little bit better. I'm going to get rid of grid lines, chart junk, and I'm going to say height affect weight, question mark. So looking at this, does there appear to be that upward association that we had surmised or hypothesized. So as we move this direction to the right on the x-axis, increase height in inches, does the weight tend to go up? It looks like it does, right? And so, you know, it's somewhat maybe linear. So what we could do, if you recall, we can add trend lines. We'll do a lot more of this in later units. And we want a linear, display the equation r squared just for fun. And then I'll move it over here, hopefully. Right. So it's saying as I get an inch taller, I gain weight in about 4.5, about 4.5 pounds for each additional inch that someone is tall. The r squared tells me the amount of variation of weight that is explained by height. So this height explains about 28% of the variation in weight. And the other thing we might notice here too is that we have things that kind of look like columns for all the points. That's because the inches were measured in whole units. There was no, you know, your 5'9.375 inches, right? It was your 5'9", or your 5'10", or your 5'11", or your 5'2", right? So it doesn't appear that there's any in-betweens, so that's why we get these columns. So that's one association between variables that we could explore. We could also say, well, we could also explore individually. Is the weight affected by whether or not we're male or female? So let's try that. So I'm going to do that. And then select all of the weights. So this should work because female's off on the left, weight's on the right. So let's insert scatter, and let's bring it down here. Female effect, weight. So what do we notice? There's only two columns, 0, which means that you're not a female, or 1, that you are a female, right? So let me get rid of some of the chart junk again, the grid lines. I'm going to go ahead and change this to, just because I don't like it all the way over there. I'm going to go negative 0.5 up to 1.5. All right, and that should be good. And I'm okay with it starting at 0 here. Well, let me change it to what we started with on the other one, which was 80. Okay. So looking at this, what does this tell me? Well, it looks like it's pretty obvious that females in general weigh less than non-females or males. That should make sense to us, right? Usually females don't weigh as much as males. So we could also go ahead and fit a trend line. And in this case, it'll be linear again. And we will display the equation and the r squared. So interestingly, the variation in weight, there's more explanation by whether or not we're male or female. Actually, that kind of makes sense, right? So if we're the same height, but there's a male versus a female, generally the female is going to weigh less. It explains 42% of the variation in weight based on your gender. And so what does the negative 41.256 in front of the x mean? Well, it means on average, females weigh 41 pounds less than males for this particular data set. Right? So that's on average, because we're doing it over all of the different individuals in this particular data set. So there's two different scatter charts that we think different variables affect the same variable, weight. We looked at them individually. Right? And we could do the same thing with age. Age would look something similar to the weight in the sense that it would have a bunch of single columns going on, right? Because we noticed that it's all whole numbers over here for that. So you could try that on your own and see what you think. So that's scatter charts. And again, we saw those at the beginning, so you should be somewhat familiar with those by now. And we'll do even more of those when we get to other parts of the course as well.